So when will we start?
I think they forgot they have a meeting on Zoom. Can anybody update when this meeting is going to start?
Huh?
When this meeting is going to start, Dr. Danish Rahman, Dr. Amin Wani, or its CUK host, can anybody explain?
I will start at 4, sharp at 4.
At 4 o'clock.
Yeah, 4 o'clock.
Okay, thanks for the update.
Is there any problem, sir?
No, we are just waiting for the dignitaries to come up and the participation will start.
Vivo 16, I think your camera is opening. It's better to, I think, inform you about your camera is open. Maybe the back camera or the open camera. So your visuals are there on the screen.
Hello.
Hello.
Hello. Assalamu alaikum.
Walaikum assalam, sir.
Sorry for being late, as there was multiple Zoom links, so I didn't know which one I was supposed to.
No problem, sir. Great day for us. We have speaker like you over here. We are ready to sacrifice our night as well over here.
All right. So that's good. It's morning here. It's still dark. So
So it gives me a very good afternoon to everybody. We have Zoom online streaming as well as we have YouTube live streaming over here. I'd like to introduce my Honorable Vice Chancellor, Professor Merajuddin Mir in Efficiencia, and Professor Mohammed Abdul Qadir, our worthy registrar. We have to just leave early a little bit because of some emergency meeting in the state. So,
Dr. Abid Sab, Dr. Abid Sab,
yes, sir.
Dr. Abid Sab, we are on the line. So we are because of some emergency, we had to move. So,
Yes,
but
sir.
we are online. You know, Honorable Vice Chancellor is also with me. So, Johai, you can take. He is also online.
Thanks a lot, sir. God bless you, sir. So, we have our son of the soil today, Professor Khalid Shah. We are humbled that he is serving the Harvard Medical School at a very great position, Director Center for Stem Cell Therapies and Imaging. And more importantly, whatever he has done in last so many 2 decades, at least in the therapeutics, as far as cell therapy is concerned, and it has not got only the scientific attention, it has got world application-based translation attention, published Nature Neuroscience, Nature You Cancer, PNAS, Journal of Clinical Investigation, Stem Cells, Lancet Oncology. More importantly, for the last few years, we have been listening all across from the international media, from BBC, CNN, and the important aspect of his work is he has used the modern technology, case 9, which is regarded as the most important and breakthrough itself as the technology is concerned. He has executed the brain cancer. So, one aspect of his talk is change driving innovation and technology. He has founded 2 biotech companies that is,
Dr. Abid Sab.
yeah, sorry, I can't hear you. Hello?
from Wageningen University, Netherlands. In the area of the plant sciences, it is one of the rare occasions that we have person from plant sciences and who have achieved such a great in cell therapy and stem cell therapy. Give us great confidence, especially the scholars, young scholars, that we can change our research area at any stage. Coming from the plant science, because plants have most of the cells in 2 different stages and induce pluripotency in other cases. Then we had moved to the postdoc from year 2001 to 2004 in Harvard, and presently, while he is serving as a director, before we could start formally the talk, I would request our Honorable Vice Chancellor to say a few words alongside our worthy registrar based on their convenience over there, and because they are right now driving the car. Thanks, sir. You too.
Thank you, Abid Sab. Before I request the Honorable Vice Chancellor to speak few words, I warmly welcome Shah Saab. We were supposed to have some emergency came and we had to just rush out of the institution. And we warmly welcome you. Am I audible to all of you?
Yes, sir.
Now, because of the 2G issues, because we are moving also in the vehicle, it's difficult. Anyhow, to Joha, I warmly welcome Professor Khalid Shahab, and he's our son of the soil. And you are speaking on a very, very important topic, which is the topic of the future. In fact, how to change the mindset in us, and how we have to just drive through innovations and technology. I understand the fact that now the era is there where these boundaries have been boundaries have vanished from different sciences and technology, and we are supposed to just think differently, think innovatively, and use the technology for the betterment of our community, for the betterment of our welfare, for the betterment of our student output. And I think this topic, as I was given to understand by Dr. Naushin, is that it will be purely non-scientific also, so that other people get benefited from it, those who are not from the scientific background or hardcore background where our worthy speaker is from. I understand the fact that we are at crossroads as of now. Technology has really revolutionized. World is in our hands. As of now, we could never have thought of that, while we are moving in a vehicle, we could still be connected across the world. And on one hand, we are having the changing technologies. And on the other hand, we do have to do everything for the welfare of our society, for the welfare of the community. So we have to think differently, think innovatively. I warmly welcome you and would have loved to be a part of the discourse there, while in my own colleague with my own colleagues. I now request Honorable Vice Chancellor to formally inaugurate this the kind of lecture, and I hand over my mobile to Honorable Vice Chancellor.
Good morning, good evening to all of you. I join Dr. Abid and my colleague Professor Zargat to welcome Professor Khalid Shah to this webinar, who is going to speak on a very, very vital topic, changing the mindset, driving innovations and technology. Well, I am very happy that Dr. Khalid Saab is son of the soil, and he is speaking at present from the other part of the world, and where perhaps it will be a morning time at this juncture. And I am also happy to see that almost all the colleagues are offline in the university committee room, in the university seminar room, where we too were supposed to attend in person, but due to some urgent meeting, we had to leave the campus. Well, Dr. Khalid and zoology under the School of Life Sciences. And I am told that you continue to guide us, and I hope in future you will continue to guide us so far as the research and quality teaching as far as this topic is concerned, which I would like to underline, changing mindset. For any change, whatever it may be, unless our mind is ready to accept it, obviously it will not come with the desired results. We have seen in the past the societies, the institutions, and even the individuals change. They had to remain behind and they could not participate in the race. And thereby, I believe you will be going to discuss various contours, various parameters, and various issues regarding the mindset, which one has to be always not frozen. They are changing world. And more or less, this mindset we have to keep open in the given circumstances, while where this COVID-19 has posed new challenges to the world at large, especially to the educational institutions and the youth thereof. I wish all the best to this webinar and would like to request Dr. Khalid Saab whenever he gets a chance or whenever he gets an invitation near future, after we are free from this COVID-19 pandemic, kindly do visit Kashmir, kindly spare some time with us here with our young faculty, with our young scholars. And I am also glad to inform you that one of the senior scientists, Professor Muhammad Yusuf, who was working in one of the prestigious research institutes of the country, he has very recently, rather yesterday, joined our family as a professor and dean School of Life Sciences. I think he'll be there in the chair because we are just a 30 members and extend my congrats to all of you. And I'm happy to declare this webinar as open and take the liberty to inaugurate. And hopefully you will get something beneficial inputs. Wish you all the best, all the best. Thank you very much.
Thank you so much, sir. Thanks a lot, our Honorable Vice Chancellor, Worthy Registrar, Professor Mohammed Abdul Zargar Sahab. May I request once again, and at the outset, I am very thankful to Professor accepting our this and more culture being so early and speaking us in. So I would now only request start this wonderful. Thank you so much.
Thank you all. Again, thank you for the warm welcome, and of course, it's a pleasure to always speak with people back home and learn more what is happening on the ground and see how we can influence in any way or shape or form. Staying here outside Kashmir. So before I start, I think I just want to know who is the host because I can't share my screen. So if the host can enable the screen sharing so that I can share my screen.
Yes, sir. Yes, sir. The screen can be shared, sir. Yes, sir. Host is just one of our colleague over here.
All right. I can do that now. Just a second. Let me share my screen. Yeah, I think while I was listening to all of you, there was a lot of intermittent, pauses in between. I think it's 2G. So if you at some point not able to hear me, please text me in the text box so I can stop. Can you hear me?
Yes, sir.
All right. So, I think the topic is very, very broad. It's one of the new things of how we drive innovation and technology, but I'm going to talk a little bit about the mindset, the innovation, and then of course, our own work on cell-based therapies and how we have sort of brought innovation into the field. Before I start, one of the most important things to realize is that we tend to somehow live in the past, and that, of course, the past is a part of you. But if you live too much in the past, you're compromising your present and you're compromising your future. So my humble advice to young people in the audience and to anybody in the audience, of course, keep the past in mind, but try to live in the present and look ahead. And so this goes all back to all the religions, all the cultures who have actually lived in the present and looked into the future, have done historically very well. So this is one of the themes of what I'm going to speak. But let me start with mindset. I think one of the questions we always ask how much is the influence of nature and nurture on us? We sometimes think, oh, this person is naturally good, but science has now told us that 10 years before it was like 50% nature, 50% nurture. So your genes and environment will define you as an individual, and 50% will be the nature how you are. But that has now changed. And if you look at the current science, it's saying 30% nature, 70% nurture. That means how you're brought up, how you interact with people, whom you interact with, that defines who you actually become. So again, going back to historical times and all religions, they will always tell you that you have to have a good company. That will basically develop you. And you might know your parents telling you, be in good company of friends. And there is a reason for that, because these people who are around you help you develop. So take home message, nurture is an important component of one's development and of course, one's education, one's behavior and influence on the society. So with that, you basically have two mindsets. I was in Malaysia a few years ago, and I was with my colleagues on a symposium. And every time, so it was a joint symposium, and every time somebody asked a question from the audience to the speakers from Malaysia, these people tried to defend it. And then one of my colleagues from Boston, he said, could you tell me why they are angry when somebody asks them a question? What is the reason behind it? And I couldn't answer because I didn't know why. So I asked, and the reason for that was the person who was giving the talk was sort of not being wanted to be questioned. So the person was saying, okay, this is what it is, and I don't want to be questioned. So, but the audience was asking the question, and they have the right to ask the question. You don't have to defend. If there's a good answer to it, give it. If there is no good answer to it, say, I don't know, maybe you are right. So there comes the mindset. So when somebody questions you and asks you, maybe you should do it this way, you have to be acceptable. And that is a growth mindset. You have to accept that maybe something is not right that I'm doing, even at a scientific level or even at your personal level. So the two defined mindsets are the fixed mindsets and the growth mindset, where in the fixed mindset, you avoid challenges, you give up easily, you ignore criticism, and success of others bothers you. In the growth mindset, success of others inspires you. You embrace, you persist in the face of setbacks. So that defines the growth mindset. So it's an open-minded thing. You do well yourself. You expect others to do well as well, and you are open to criticism. So I'll give you a few examples. Here is an example of natural versus great athletes are natural. So you remember, maybe some of you remember when Muhammad Ali was fighting Sonny Liston in late 1970s or early 1970s. Liston was very very powerful, very experienced, and knew how to box. how to fight. But Muhammad Ali wasn't. He was not as strong as Liston. He lacked all these classical moves, and didn't block the punches and all these things. But he had the strength. And if you remember from the TV those days, he would always say, "I'm going to beat the Listons. I'm going to beat everybody. I am the best." So he's in his mind, he was always ready that he would win. Although maybe he didn't have all the technique, but it was his will that led him to fight Liston and beat him number of times. And this is not, that means that, you really don't have to be talented initially. You can adapt, you can develop over time if you really want to, because you have all your life to get better. And if you ask yourself every day that I want to get better, you will. And there are other greats like, Elvis Presley and Jackson Pollock and Charles Darwin even. I mean, these were not, really good in high school or in college, but later on developed to be great people, successful in their field, and whatever they did in life. So I think we cannot justify people. We cannot justify the fact that, oh, some people in the 10th grade or the 12th grade didn't get enough marks, and they were not good enough. You also have to understand the system. I mean, say our system tests memory, and the modern system tests number of things. So there are 5 areas of the brain which are essential. I might not remember all 5, but 4 of them, I know there's memory, there's problem solving, there is attention to details. There are 2 more, but I think these are the different areas of brain. And some people are good with memory, some people have great attention to details, some people have great problem solving skills. So as you grow, life evolves, and you might know that the best engineers and the best doctors and the best lawyers were not the people who were very good in their school or the grades. They developed later on, and that's what history tells us. So there's always a chance. Don't qualify yourself on the grades that you got in the 10th class, 12th class. There's life beyond that, and you can always, if you have that curiosity in you, you can develop as an individual. And one of the other examples of the fixed mindsets is John McEnroe again, 1980s, early 1980s. McEnroe was one of the greatest tennis players, was number 1 for 4 years, but didn't want to learn. He was really talented. He was notorious for his temper, and always lost. He blamed it on others. So, and that was it, 3-4 years and he was done. But he had his great time because he didn't want to learn. He didn't want to, so the implications of failure there are enormous if you have a really fixed mindset. There could be great people with fixed mindsets, but not very long lasting. So, I'm going to turn this, mindset into knowledge now. Again, so do you have the capacity to keep learning? And now the studies on Alzheimer's and other neurodegenerative diseases are teaching us that, as long as you keep learning, you will do fine. You will get less neurodegenerative diseases. You're not prone to Alzheimer's and other neurodegenerative diseases. So learning is a key part. I'll give you an example. If some of you have been to London, London streets are like a maze. And the London drivers, before they start a taxi or get a taxi, they're asked to memorize 2,500 streets. Even now, in the time of GPS, they are still asked to memorize 2,500 streets of London before they can get the license. And some years ago, some scientists did the functional MRI of their brains and found that their hippocampus had developed differently than the others who didn't learn in the 2,500 streets of brain. And if you take a cab in London, they without the GPS will take you wherever you have to go, because they have memorized these 2,500. And these are old people. I mean, these are in their 40s and 50s and 60s, but they have to learn this to run the cab. So when you're pushed to do it, you will actually do it. Every individual has an incredible capacity to learn and to deliver. The question is, do we really want to learn? I think that is the big question. And we should ask ourselves, am I really learning something every day? And people who do that become successful one way or the other. So now, I think you can link this to innovation. I've tried to sort of connect the mindset to the learning capacity, to knowledge acquiring. Now, how they connect it, mindset and innovation. And I think one of the key things in innovation is that if you don't think really deep, you will not be innovating anything. So the key to innovating is to go to the subconscious mind, to cultivate that burning desire that I really want to change the status quo. And unless you change the status quo, you won't be innovating. Innovation is not an increment. It's something different. So it has to be that unless you're pushed to change, and COVID is a classic example, because finding therapy for COVID or vaccine has pushed us to the wall, and something really big will come out because we really have to find something to combat the disease caused by COVID. So innovation is, again, I don't like the way the word innovation is used. People use innovation, for anything, even if they're doing something incremental. Oh, it's innovative. Innovation is defined differently. I think innovation is basically an answer to agitation. When you're not happy with something, you say, take an example of iPhone. Steve Jobs, when he made an iPhone, his ideology behind making an iPhone was that the current phones are obsolete, they are useless, they cannot be used. I need something user-friendly that even a person who is uneducated can use it. It's everything in the hand, everything is run on the iPhone, and that's how iPhone evolved, because this person was not happy with the phones before iPhone. He said that is, I'm not looking at old phones. I'm not giving you incremental innovation. I'm going to really come up with something new. And here you go. iPhone is one of the 20th century or 21st century marvels, although it has spoiled the young generation that most of our kids are on iPhones all the time. But if he hadn't done it, somebody else would have done it. But that's some kind of innovation. The other guy, whom I admire, is Elon Musk. You might have heard about him. He's the founder of the Tesla, the cars, the ones on that run on electricity or the battery. And he's the guy who believes that we can live on Mars. He took the program from NASA. NASA stopped its mission to Mars, and he thinks that we can actually go and have regular flights to Mars. And he had one successful flight. So among all these things, he's looking at the future. He is not looking even at the present. He's just looking far ahead. And I think that defines your three horizons of innovation. So where you have the now, you have the transformation, and you have the future. And if you look at the H1, the first horizon, and what you see is that if you go with status quo, you have the structure, you have everything, it will in time go down, the red line. you will see it going down in time because, 10 years from now, 15 years from now, this is all obsolete. Now, the second one is the blue line is the disruptive innovation. And one of the examples of this is Netflix, when it went online, all these streaming movies and streaming programs, it was what they used to do before. They used to send discs to your home and you can watch a movie or something. And then they went somewhere in 2007, 2008, they said we should move this platform over internet. And that's sort of disruptive innovation, although over time they end up at the same place where they started, but they disrupted something. The third one is the transformative innovation, where there's no use of the innovation currently, but in future it will be in vogue. So that's the third form of innovation. That is the transformative innovation. That is what you have to be looking at. And that is very risky because in the current form, it doesn't have a use, but it will have a use somewhere down the road. So, I'm slowly going to what we do in my center and what I have done or what my lab has done over the last 10 years. And I'm going to introduce through the reprogramming of iPS cells. And what that means is the studies from Shinya Yamanaka, who won the Nobel Prize in 2012, his concept, the concept was that the once you have a fully differentiated cell, a skin cell or a pancreatic cell or a bone cell, this will never go back to its original stem cell. So the cells, once they are differentiated, they will never go back to their undifferentiated state. So what Yamanaka did, he took 4 transcription factors, OX4, SOX2, KLF4, and MYC, and actually put them back into a fully differentiated cell like fibroblasts, and created stem cells from this, which is huge because it actually refutes Darwin's theory that once the individual is created, you cannot go back to the seed. So he basically is what he pioneered was that you can actually take a fully differentiated cell and go back to it and create a seed out of this. The implications are huge. So you can take a diseased cell actually and reprogram it, make it a stem cell, and then make it a natural cell again and put it back into the patient. So IPS, it's called induced pluripotent stem cells, and has revolutionized stem cell biology, stem cell technology, and is being used in a number of patients over the last 5-6 years. So our studies, we focused on 10 years ago on how do we actually use stem cells to kill tumor cells. So what you see here is a red stem cell and a green tumor in the brain. And the idea was that, the red stem cells, we know they migrated to tumors, and can we produce something from red cells that can kill green cells? So we've done a number of studies. I will explain a few of them. But a couple of years ago, we sort of thought that is not going to really work because you have to take somebody else's cells, modify them, put them back into the patient. It's not going to work for cancer patients. So we sort of pioneered something new. We thought, why not to use cancer cells by themselves? So take them from the patients, modify them and put them back into the same patient. And then gene engineer them and gene edit them with CRISPR technology and see if you can actually kill both populations. First, kill the cell that is in the tumor, and then kill the cell that you have introduced into the body. I'll talk a little bit more about this towards the end. But with the stem cell technology, we and the other cell-based technologies that we have developed in the center, we basically have 4 different types. We have the engineered stem cells, we have the iPS cells, we have the engineered cancer cells now, and we have also CAR T cells. So they have different, so the engineered stem cells and the iPS cells, these are all allogenic. So you can take them from healthy individuals and put them into a patient after modification, or for the other ones, the engineered cancer cells and the CAR Ts, you can actually take the patient's own cells, modify them, and put them back into the patient. So what we've done, we have engineered stem cells releasing therapeutics that bind to different receptors on tumor cells or tumor-associated endothelial cells, and now also immune cells. And we've shown cell killing in number of different tumors, but most of our work has been on the tumors in the brain. And I'll share with you a few videos. Hopefully you will be able to see them. They will define what kind of work we've done. One of these videos is, so a green is a stem cell, if you can see it, releasing therapeutics that we have engineered the green cells with, and then it's killing the red cells that have specific receptors for the therapeutics that are released from the green cells. And the green cells are not killed because these are the stem cells producing the therapeutics and killing the red cells. The other example of the video that I'm going to share with you is the virus released by the red cells. So the green cells are the tumor cells, and the red cells are the virus-releasing, oncolytic virus-releasing cells. So they first kill the red cells, then the red cells release the virus, and it kills the green cells, become red, and then everything dies at the end. So this is the power of the cell-based therapies. These are 2 examples from a number of papers that we have published before, showing different modes of killing. One is viral oncolysis, the other one is apoptosis. The big question in cell-based therapy is, how do we actually translate therapeutics? It's great to publish, but how do we actually go from bench to bedside? And that's been really the core focus of my lab and the center that I have now developed. Again, the key there is to understand what happens in a patient. So for example, a person has a glioblastoma, a grade 4 brain tumor in the brain. And what happens to this patient is, in majority of the times, this patient gets operation and gets resection. The tumor is removed because tumor creates an intracranial pressure in the brain and has to be removed. And in 90% of the cases, the tumor is removed. And then if you look at the phantom of a person's MRI that had a tumor and had it removed, you see all these cases. These are 10 patients. In all these cases, a cavity is created. A small cavity is created. And we basically focused on this cavity because we believe that after the tumor is removed, we basically need to treat locally at the site of the tumor. So we have developed, of course, we have the stem cells that release therapeutics that can only kill tumor cells. Now we have also encapsulated these tumor cells because when you place the cells there, they get washed out. So we have placed cells in the resection cavity. And as I said earlier, that we had to develop the right models. We have to have delivery and then the safety and patient stratification. So what we did, basically, we implanted the stem cells locally in the tumor resection cavity. And you see that you get 100% survival in mice. And that now we are sort of translating this therapy. We have also incorporated a kill switch because many the agencies that give approval for use in patients want a safety switch in your stem cells. So we have incorporated HSV-TK. It's a herpes simplex virus thymidine kinase, which can, once you activate it with GCV, ganciclovir, you can actually kill stem cells. And then you can also use it as a PET imaging agent. So we have all the tools now, to take these therapies into the clinics. And this is sort of a clinical paradigm, how we're doing the clinical trial with this, where we take patients' blood, we actually look at whether the receptor we're targeting in the brain is in the blood. And in the meantime, we have the stem cells banked in the cell bank at a GMP grade facility. We can take these cells and put them back into the patient when at the time of the operation. So this is sort of how do we translate what we have developed. But while we're doing this, I mean, we were also thinking, can we develop something new? And one of the key things in that translation was creating an industry or collaborating with an industry. So we've created a few, from this work, one company that actually is being funded to take it to the clinical trials. And that's important, because if you don't connect academia with industry, anything you develop within the academia is not going to move forward. It will stay as a cool paper, but it's not going to end up in patients unless the money comes in from industry and industry takes it to the next level. So what I was saying is that, of course, while we were developing all this, we also thought that we have to come up with something new and something bigger, something brighter, and we started exploring, looking at cancer cells as therapeutics. What I mentioned at the beginning of my talk, how do we can we actually use cancer cells by itself to kill cancer cells? When we initiated this idea in the lab, people thought that, I was a bit crazy looking at cancer cells. So this is 5 years ago, 6 years ago. The concept was, again, coming from the knowledge of understanding what happens within the tumor. So I'll give you an example. If somebody has a breast cancer, from the breast cancer, the cells go into the systemic circulation. They're not just staying in the localized at the site of the tumor, but they're also going into the bloodstream. And if you have 1 billion cells in the tumor, around 1 million cells go into the bloodstream. And out of those 1 million cells, they try to go to different organs. They try to go to liver, they try to go to brain, but they don't seed there. I'm talking initially when somebody has a really primary tumor, they initially don't seed there because the tumor and the organ is not leaky, and they get rejected. So what they do, they come back to their own tumor, and they like to be there because the tumor allows them to come back and sit there. And this is where you get a lot of mutations, but the self-homing of tumor cells is the key, because they can actually come back to their own tumor. So we thought, this is known. Why can't we take the cells that go in circulation, take them out, and gene engineer them, gene edit them? The technology had evolved over time, and place them back into the patient. So we had two approaches, where one, we had an allogenic approach, which is pretty straightforward. We take a patient's tumor, which is therapy resistant, and we take it from one patient. We gene engineer it with a ligand that releases the killing agent and a kill switch that we can actually eradicate these green cells ultimately and put them in patient B. It's very straightforward. So, but the key for that is that the patient A's tumor has to be therapy resistant, and we can actually take that and put it in patient B, which is therapy sensitive. And we did that. We took the patient one's tumor and put it in a mouse model and treated the patient two tumor, which was sensitive, and you see again, you get almost 100% survival. The green cells go to red cells and they kill the red cells, and ultimately we can kill the green cells by activating the kill switch. But we thought, taking it from one patient and putting it in another patient, it's not going to be that practical. How about taking it from the same patient and putting it in the same, taking it from the patient and putting it in the same patient? Now for that, it's very important that the original tumor is therapy sensitive. So the idea then was, when we resect the tumor, we make the tumor cells therapy resistant by CRISPR editing, gene editing its receptors. So the ligand doesn't bind to the receptor and they are resistant. And then we bring the ligand into the cells and with a kill switch, and then we go back into the same tumor at the time when it reoccurs in a patient. So a lot of engineering, but possible. So we took TRAIL. TRAIL is one of the ligands which binds to two receptors, death receptor 4 and death receptor 5. I've called it here receptor A and B. So we knocked out both receptors, and then we engineered the cells to express the ligand TRAIL and a kill switch. So here's some data that when we knock out one receptor first and then the other receptor. And what happens is, when you knock out one, you get 50% resistance to TRAIL. And if you knock out both receptors, you get 100% resistance. And then you engineer, so we've done this for a lot of cells. We've done this for T-cell lymphomas, breast cancer, GBMs, and prostate cancer. But most of the work was done on the GBMs. And then again, you have the gene engineered green cells, and the red cells are the target cells. And you see the green cells are now killing the red cells. And then ultimately we can kill the green cells by activating the kill switch. Very complex, but the idea is really straightforward. Take a cancer cell, gene edit in such a way that it becomes resistant to the tumor, resistant to the drug, and then make it release the drug so that it can kill the original tumor cell, and then you can kill the gene engineered cell with a kill switch. And we've shown it in different models. One of them is a resection model, and you see again we get almost 100% survival in the GBM, the brain tumor model. We have also done this in breast to brain metastases, which are different tumors, and you might want to know that when somebody gets metastases, somebody has a primary breast tumor or primary melanoma or colon, and they get treated with chemo and radiation initially. Later on, after a year or 2 years, or in some cases 5 years, they get metastases to different organs. And one of the prime metastases area is brain. And when they go to the brain, they don't grow as primary brain tumors. They grow as macrometastatic tumors. You see these small dots. So they're everywhere. You cannot basically resect. You cannot actually do much because there are multiple tumors in the brain. So we've developed a way to inject, to create first the tumors in the brain, and then developed a lot of models which mimic micro and macro metastases, leptomeningeal metastases in the brain. And then in this case, we've not tested these cancer cells yet, but this is with stem cells targeting EGFR and TRAIL receptors, and we show that you get substantial differences in survival when you inject this intrathecally in the brain. You see, it's targeting the leptomeningeal metastases in the brain and resulting in survival. So in short, I think, I gave you some of our work, what we have been working on, and how we actually are thinking of, while we're doing the work, we're thinking ahead of what can we change to make it better. And while this work is going on, we also thought, okay, this is fine. We got it published in Science. The question was, how do we go beyond this? And while we were doing this, we thought immune system is a big component of this. So our next work that will be coming out in a year or so, inshallah, will be more focused on how do we make a vaccine out of this? How do we use a cancer cell vaccine to treat both primary tumors and metastatic tumors? And that's work in progress, and hopefully, inshallah, it should be ready by early next year. So what I just told you, and I gave you some examples from my work, and people have worked in the lab, is about mindset, is about knowledge, is about innovation. And if you don't have the right mindset, if you don't have enough knowledge, you really cannot innovate. It's very basic. You have to accept that the current status quo is not acceptable, and then you can innovate. And the other component that I didn't discuss, maybe next time, inshallah, is that when you innovate, you need to orchestrate as well. You need to have a system for that innovation to be successful. If you don't have a system, you can keep on innovating, but you cannot implement it. So creating systems, I'm a big believer in creating systems that run smoothly. And I urge universities like yours and departments like yours to create systems where people can come and innovate and actually develop something big. And from our work, we will only innovate when we understand what is the current treatment regimen for each cancer type, and how can we actually change that. And for brain, we know that brain tumors are almost incurable, and I believe that all the medication at this point, the chemo and the radiation, is obsolete for brain tumors. So that's my thought process. I think it's not working, and we know it's not working. For 30 years, it hasn't worked. So we got to change something. I believe that we have to go locally at the site of the tumor, because these patients do get operated. So we can actually go locally there. And so cell-based therapies is the ideal therapy, because you cannot put drugs directly into tumor. It will affect the normal brain. So that's why I think if we can sort of focus more on this and leave everything that systemically delivered drugs will not reach brain, you will have something very novel. So I really normally put this slide very much at the front of my of my talk, because I was talking about innovation and mindset change. I didn't bring this up. So there are lots of people in my lab from different countries. I've trained people from almost 42, 43 countries. I believe in diversity. I believe in giving opportunities to a wide range of people who are really who really want to do it, but are also have some kind of knowledge that they bring in. So it's all, nobody really comes in unless they meet the criteria of that there is certain level that they can bring into the system. They bring some knowledge with them and they learn more. So thankful to all these people, because without these people, the work will not be possible. And all the people, all the collaborators who have always opened arms and have let me into their work schedule and labs when I was starting, and all the funding agencies. And I will leave you with this one. This is a quote from Rumi. I'm a big fan of Rumi. I read quite a bit of his works. And this is how much And I think there is there is a hadith about it as well, that if you enjoy your work, you will get the joy, you will get the pleasure. But the real work, not the work for the money, but that you're doing it for something, the rest will come. And if you want to be happy, you have to enjoy work. That's the key. You just and the rest will come. Money is an outcome of what you do, and money always comes when you do something right. And if you do this right, you will get it. So thank you so much. Are you still there?
Are we audible, sir? Am I audible, sir?
Yes, you are.
Yeah. So the group has successfully tested their work in metastatic mouse tumor models, as well as found clinical relevance, and because of this translational part of it, and more importantly, the drug resistance which we see in the chemotherapeutic regimen. So using this model, there is now being explored all across, and taking the lead from Dr. Khalid's group. Stem cell-based therapeutics is being exploited all across tumors in the world to eradicate various cancers, prostate, other pointers were always in his group. So not only these stem cells, cell technology, these therapeutic aspects, let us know that stem cells have found various implication in the regenerative medicine, especially neurodegenerative, metabolic, and bone marrow transplantation. Besides, in future, we can see regenerative medicine in organ development, which is very wonderful to have you, Dr. Khalid. Still, I request, because we are being listened all over globe. We have stopped registration yesterday evening because we are almost more than 1,000 entries over here. So I request any of all across whosoever may ask one or two wonderful questions to Dr. Khalid. Anybody?
Thank you so much. Happy to happy to answer questions as much as I can. You can also email me. I do get 200-300 emails a day, so don't expect an answer from me the same day, but in a few days, inshallah, I should be able to answer.
So anybody having question all across, I think we have wonderful scientists working in this area. Dr. Muzaffar Mancha, our colleague who is there. Ask some question. Dr. Muzaffar. Anybody else who wants to have a question? Please raise the hand. Those who want to make it more interactive, ask the question.
Yeah, so I see some of the questions in the chat. So should I read and answer them?
Yes, sir. Yes, sir. You are wonderful, sir. It will be wonderful. Yes, sir.
Yeah, I think there's a question from Dr. Ghulam Hassan Dar. Have you tried to use extracellular vesicles for delivering toxic molecules to kill the cells instead of using the whole cells? No, we haven't, but there is the talk of extracellular vesicles that you can get from the cell. So we believe that to isolate extracellular vesicles from cells first and then load them with the drug is a nice innovative way to deliver. One of the issues with that is that what we want is the cell to continuously produce the drug, and that's the huge advantage. Because all these drugs that, the trails, the nanobody trail, the viruses we deliver have a very short half-life. And you just cannot put a protein in the extracellular vesicles, because, they will be there for 2-3 days. That's not enough. So with stem cells, it's very sustainable, and you can actually kill tumors that are far away from the primary site as well. So I think the extracellular vesicle technology is evolving. And one of the things that we're looking into is taking the secretome from the stem cells. So engineering the cells and then taking all the cell components out, just taking the secretome and putting it. But again, I think the difficulty will be how long can you produce the drug? And stem cells are, much, much more helpful in doing that. So we're also exploring the T cell technology now, which hopefully we have some data, should be able to publish this year, inshallah. So combining stem cells and CAR T cells may be a way forward.
Sir, do you want to select any more questions from the chat?
Yeah, there are a few more questions. There's a question about from Sheikh Ishtiaq saying, what is your view about using plant-based products to induce apoptosis in cancer cells? I mean, there's a lot of products out there. Green tea causes apoptosis, but you have to be, really, really practical, because in tissue culture, many agents cause cell death and apoptosis in tumor cells. But the practicality is that when you're actually treating a tumor, what will work? Because any drug that works with in culture doesn't go to the brain. Most drugs do not go to the brain. So brain is very privileged. When human beings were created, brain was kept as a very privileged organ with blood-brain barrier, not allowing drugs and viruses and bacteria to pass through the barrier. So the coatings in the vessels of the brain have an extra layer which create a blood-brain barrier. So that also prevents drugs to go across. So I would rather have something very natural, like stem cells or T cells or oncolytic viruses that we can use for treating. So there are a number of questions. So I just will read, read a few. I think there's a question from Dr. Omar that why is cancer uncommon in other animals and why is it common in humans? No, animals do get cancer as well. Dogs get gliomas, dogs get brain tumors very readily. I think we don't monitor animals when they die. What is the cause? And in US, because there's a lot of pet care and dogs particularly get a lot of tumors. Humans, I think if you look at the history of last 100 years, I think modernization is one of the main causes, the radiation, the toxic waste, and the impure water. All these factors somehow are responsible for cancer. Maybe animals, who are not exposed too much to it, or have a short life within 5, 6, 7 years, and not enough time for them to get a cancer. There is Yeah, there's a question from Misbah Majid. Is that what are the risks of the procedure itself, and are there any possible side effects? A very good question. I think there are no risks because the procedure is done already in the patients. You get tumor resection as part of the therapeutic regimen for these patients, and then we are going locally with stem cells. And if there is any side effect, we do have a kill switch that we can kill the stem cells if need be. And this is one last question from Hamidul Abad saying that can we use viruses to kill cancer cells? Yes, we have oncolytic viruses, adenoviruses, herpes viruses, pox viruses, myxoma viruses. All these have been used to kill cancer cells specifically because they work on replicating tumor cells. And when normal cells don't divide, so they don't affect normal cells, it's mostly the dividing cells. Those cells get killed. I don't see any other on my screen. There is, I don't see any other question. I think there is one question from Ghulam Sandar saying that what's your advice for those who want to come back here after postdoc and start working here? It is where you draw the line. Although the facilities and the quality of science will get hit. Some people want to come early because they miss home and they want to be with their home, with their family and stuff, and come back early. There's no general advice for people, although I stayed out and had to sacrifice quite a bit of things for staying out to get something. But it will depend on individuals. Some individuals do want to come back, and I know a number of people have come back to Kashmir University and have done well. Again, my advice to people is, if there's a burning desire to do something, but it has to be, focused. You can't just have it both ways. And one of the things from my personal experience has been really very focused and letting go a lot of things which I wanted to do in side by side, but wouldn't be able to do unless I wouldn't be able to do what I did if I had taken and not left those things. So to get something, you have to leave something. And I think we all, particularly young people in the audience, they have to learn that you cannot have it both ways. A bit of this, a bit of that, a bit of that doesn't help you become very successful. I think you have to let go a lot of things to move forward. That's my advice. It's my personal opinion. It's not a general opinion. But to move forward, you just need to be extremely, extremely focused.
Professor, sir, very nice lecture. And regarding the innovative thinking, you said rightly that innovative thinking means something to think out of the box, which can change the whole scenario. And even in the set technology, if we are having some innovative thinking or innovatively something, it can change the whole scenario. You have given the very nice information on the stem cell therapy and other things regarding the cancer. One of the thoughts from the homeopathic, it came that cancer is due to the more usage of the drugs or medicine. So they think that we should use the more herb-based medicine. Is there any regarding it, or how much the homeopathic medicines are useful in the cancer therapy? Can you throw a light on this aspect?
Sorry, I didn't get the last part of your question. So what was the question?
The last part is according the homeopathic thinking, that the cancer cell or cancer development is the third stage of the use of the recent latest medicine and other medicines and drugs, drug-based mostly. So, what is the fact about the homeopathic medicine? Are they effective enough or not? Or what extent these the homeopathic therapy is effective in this field?
I'm not an expert on homeopathy, but I believe in two things. I think that once you hit the age of 40 or beyond, diseases will come. And this is called aging related. These are aging related diseases. And the cancer is more prevalent after 40. You get diabetes, you get heart problems. And one suggestion, whether it's homeopathy, whether it's Ayurvedic medicine, whether it's Chinese medicine, the basic fundamental thought process is that your metabolism slows down. It's not the same when you are 20, you can go to 3 different Vazwans on the same day. You cannot do it at 50 because your metabolism doesn't allow you to do that. Now, what does that tell us? That you have to work extra hard to get your metabolism to a point where you are as same as 20. So it takes two things. It takes that you got to control your diet. Because imagine you have a car and you put a wrong fuel in an old car. What will happen? It will not work. So think of yourself as a car and you are giving it a wrong fuel. What we eat is critical. And if you eat right, you will, inshallah, be healthy. That is given. So diet is becoming a huge component, and many of you might know the microbiome thing, that your gut basically controls your immune system, controls your whole body. So diet for me is one of the key things if you want. I think that I see another question that, people saying, how do you prevent cancer? And what you eat is critical. No junk food, less meat. You walk 4 or 5 kilometers every day, and you will be healthy. I think that is, and you will be less reliant on medication, because after 40, you will basically need some kind of medication for diabetes and stuff. So you can actually reverse all these by not trying to defying age. And once you sort of defy age, not mentally you have to say, yes, I'm getting older, I'm getting wiser, but physically you have to try to defy age by diet and exercise and fitness, so that you don't need pills to survive every day. That's my suggestion to a lot of people who are in the a little bit older category, but for also younger people who will be in the older category at some point.
Thank you, sir. Thank you very much. Very nice lecture.
And of course, you should not take sugar. I see another question, does sugar feed cancer? I would stop sugar. Not just the real sugar that you put in your tea, but all the sugar related foods. And it's not the sugar, it's actually the carbs, the wheat, the carbohydrates. You should significantly reduce that. Again, I'm not an expert. This is my personal, personal advice. Not a very scientific advice from me, but we are starting to work on microbiome now, looking at how gut microbiome and gut bacteria influence cancer. That hopefully we should get some insights in next 3-4 years.
Hi, Professor Khalid. Thank you for nice. This is regarding that brain metastasis model. So I was wondering, did you look into account the other sites where this exercise, or did you in such a way so that they are metastasized to brain?
No, we focus on brain mets. So of course, there are other sites, but our models only create metastases in the brain. We don't look at others because the other metastatic sites are easily treatable by systemic drugs, systemically delivered drugs, but the brain ones are the most difficult ones to treat. So we have only made models that develop metastases in the brain.
So my general query is, who should not ask, but I am prompted to ask Dr. Khalid, how can these stem cell based therapy find the generalized use as far as personalized medicine is concerned? Because so we have been more as a chemotherapeutic agents in the form of the personalized medicine. So how cancer stem cells will find this generalized use in next 5 years or 10 years down the line, as far as personalized medicine is concerned?
Yeah, it's coming. I think cell therapy, cell and gene therapy is in vogue now. There are CAR T cells that are being used in patients. So I'm hoping in 5 years it should be pretty readily used. I think more importantly, looking at immune-based, cell-based immune therapies. Immune therapies have sort of revolutionized treatments for melanomas and other cancer types. So the anti-PD-1, anti-PD-L1, and anti-CTLA4 antibodies are given to melanoma patients and work very well. So we are trying to develop cell-based immune therapies, and hopefully, we and others in the field who sort of lead the field should be able to have some of it in the clinics, and it becomes the norm, particularly for tumors that are untreatable at this, mainly the GBMs and the tumors in the brain. The survival for a patient who gets brain tumor is 9 to 18 months, and it has not changed in the last 20 years. So something has to change.
Professor Khalid, this is regarding your one of the first. So you said that for the development of human being, 50% of contribution is from culture. Is there data regarding that? And do you think it has a role? Epigenetics has some role to play here?
Again, that's not my expertise, but I think it's more than 50% from nurture. I think it's around 70% now. 30% is your nature. So so the simple example is take the same kid and place them in 2 different environments. They will become 2 different individuals. And that tells you how much nurture is important. So for parents in the audience who have young kids, 4 or 5 years of age, it's so important what parents do at home. Kids pick it up. You might not notice that, but when the kids are developing till 15, 17 years, their best teachers are their parents. So whatever you do at home is influencing your kids one way or the other. That is the nurture part. If you're innovative in your thought process, you're open-minded, you wish everybody well, your kids will become the same. And that is the crux. We sometimes don't notice that. And that is the nurture part of things. I think, of course, there is nature, 30% of the genes, or maybe 30-40% of the genes. But I'm a big believer of nurture, which is so important. The people you associate with, the people you sit with, and you let your kids sit with. So that's so important.
Thank you.
Yeah, again, this is not my domain. This is all my personal experience from what I understand. So don't quote me on any of these things.
And Dr. Khalid, on the behalf of Central University of Kashmir, and on the behalf of our Honorable Vice Chancellor, Professor Merajuddin Mir, and our worthy Registrar, Professor Mohammed Abdul Zargar, and also on the behalf of our Dean, Professor Mohammed Yusuf, who joined it yesterday. So, alongside, I am so thankful of University fraternity, and also I am thankful to all those who joined us from all across the world in this wonderful talk. And it was not only from your lab thought process only, it was so innovative and associated as well as 5 to 10 minutes were concerned. Also, breaking news years, your lab has been personally, and my colleagues, I joined. I am faculty department of listening patiently over here. Especially, I would like to thank Dr. Samrina and Dr. Asia for listening from home. And most importantly, Dr. possible alongside Dr. Nisa. Both of them making efforts of circumstances of the internet. 2-3 days they have listened everything. I will talk. So, not only thank making it possible in 2G. So, Dr. Shabiz, Dr. Najib, and also our IT staff. And we would like to host you, inshallah, once you visit Kashmir again. In next, I think you are visited physically over here in Central University of Kashmir for much more things, because it's our privilege and proud moment that you are doing wonderful at Harvard Medical School. And vice chair and thought process over there. So it is a great privilege to whole Kashmir as well as to the nation, as well as to the world, because science is being done for whole world together. Again, thank you. I will give the last word to you, Dr. Khalid, to end up this talk with your last word from you.
Yeah, thank you so much. I think, it's always, Kashmir is very close to my heart, and, we always, I think twice or thrice a day, we remember Kashmir every day. So, from a scientific standpoint, I think, I've always thought that it should, of course, what you do during the day and what you work with, it should influence you one way or the other. And the thought process is very straightforward. I mean, we don't think we have done something really big, or we always believe that there is more to do till we really find a cure for, if not the whole of cancer, but for tumors in the brain. And, at least you will see that commitment from us, both at the individual level and the collective level from me and my team. But, inshallah, when I visit Kashmir, I'll definitely visit you in good times. Hopefully we have beaten COVID by that time. And thank you. I think these questions were wonderful. please feel free to reach out to me if I can be of any help. Again, great interacting with all of you.
Thanks a lot, sir, for spending a wonderful morning from United States with us. Thanks a lot. God
Thank
bless you, and God
Yeah.
bless you with your success on professional as well as on personal front. God bless you
Yeah.
and group. God bless you. Wonderful. Always proud to host you.
Yeah, thank you. Please make dua for us.
God bless you.
Thank you.